This time we're supposed to determine the output waveforms when switch S1 is open and when switch S1 is closed. When switch S1 is open, the input of inverter is connected to the pull-down resistor. So if you have this connection, okay, you're supposed to realize that your input is connected to ground. That's why this input is receiving at this moment 0. Keep in mind that you cannot leave the inputs of gates open, right? So you have to connect them somewhere. You're supposed to connect them to VCC or to ground by pull-up resistors or pull-down resistors. Like in this case, we have pull-down resistor. Anytime we have resistor connected to the input and ground is called pull-down resistor. And you cannot have situation that, let's say, there is no resistance and you have simply switch, because when the switch is open, you are going to create errors at the output. Input of every gate which you are going to analyze has to be connected to the pull-down resistor, or pull-up resistor has to be connected to ground or to VCC or to the output of the other gate. You cannot have the situation that, let's say, the switch is open and there is no pull-up or pull-down resistance connected to the input of inverter in this case. Okay, so because I have pull-down resistor, I have 0 at the input. Now, if I have 0 at the input, output is going to be 1, okay, according to the truth table. When I have 0 at the input, I have complement of 0 at the output, which is simply 1. And no matter what comes to the input, okay, the input is going to simply receive this waveform. Okay, let me just draw one piece of it. Okay, so because the switch is open, nothing is going through. That's why I'm going to have simply on the output logic high. Okay, now what will happen if I'm going to close the switch? If you are going to close the switch, you are going to send this waveform, this waveform, to the inverter. Okay, and you are not going to have logic 1 all the time at the input. You are going to simply have this waveform at the input of the inverter. And if you want to find out what happened at the output, you're supposed to simply draw the dashed lines at every single change of your input waveform. And after that, you're supposed to look at the truth table and simply determine the output of this circuit. So if input is receiving logic 0, this is my logic 0, according to the truth table, at the output I'm going to have 1. Okay, so this 0 applied to the input will produce high at the output of the inverter. So I have high. If I have high at the input of the inverter, output is going to be 0. And again, if you are going to apply 0 to the input, output is going to be high. If I have high at the input, output is going to be 0. And if I have 0 at the input of the inverter, output is going to be high. And high is going to give me 0, and 0 is going to give me high. Now I can draw the waveform. Okay, I have high, I have low, I have high, I have low, and I have high. Okay, keep in mind that anytime the switch is closed, okay, you are going to send the waveform, okay, or we can say the signal, to the input of the inverter. Inverter is going to simply give me the complement of the input at its output. That's why this is the answer to my problem.